Today is the 22nd of April 2024, and I would like to introduce you today to the topic of Surds, Surds. Okay, thank you everyone um, who have subscribed to our channel. Okay, um, please, if you haven't considered it already, can you please think about it, and if possible subscribe? I would really appreciate that. If the account is not yours, please ask permission from the account holder. Okay, as much as I want you to subscribe, I don't want you to misuse somebody's account. Also, you can ask somebody to help you open your own account. Okay, and then click on the notification button. When upload, you get yours, it comes straight to your phone. And then when you watch, please share, like, okay, follow. um we are in a season where there's a lot of mental health. Okay, some people will get a week to the time of exam. They don't feel confident, and then they give up. They don't want to even show up for their exams. But please, if you know somebody who needs the information I'm putting up, okay, just give it to them. If it helps them, fine. If it doesn't help them, they can look elsewhere. Okay, but don't keep it to yourself. Share it as much uh, to as many people you know. And also like, share, give us nice comments. Okay, in the comment section you will see, please follow my notes class scripts. Okay, maths is full of numbers, a lot of stuff. Okay, so for instance, here um it's 140 divided by 2, which is 70 degrees. If you hear anything apart from that, go by the notes. Okay, please. Beware of scammers. Okay, beware of scammers. Be careful online. Take good care of yourself. Recap: we've been doing graph work and doing equation of lines. Okay, the equation of lines we did earlier gets involved equal to, but now we included less than, greater than, less than or equal to, greater than or equal to. Okay, so we said if the line is less than or greater than, you use broken lines, or you draw a straight line. But when you are looking for the right region, you don't shade it to the line. Okay, and then if it is less than or equal to or greater than equal to, straight line, and then your shading touches the line, and I show you how to find the region if it's an equation of a line. What I'll watch last video for recap. Okay, if I find some example, I'll do it at the some possible exam questions. The next set I'll do, because this kind of equation of the line solution is graph work, and it can take maybe 30 minutes for me to just explain to you. Okay, and then I showed you two ways of doing it. I did graph one, which I told you that was the way I was taught. You shade the right region, and then all the shading where it converges for the 3 or 4 lines, so how many lines they've given you, that will be your region. And then some other people teach it such that you will shade the opposite region. So what the region you want will come blank. But I said the problem with that is, assuming you were given one line, like x plus 1 less or equal to 5, and you draw that and you shade the opposite region, then it's wrong. You have to shade the right region. Okay, so if you are going to shade the opposite region to get it blank, remember that if you are doing just one line, you have to shade the right region. And then you have to be consistent. You don't shade the opposite region for one line and the right region for the other line. You wouldn't get. So if you are going to solve the question to shade the opposite region, you have to do it for all the lines. Okay, and if you are going to shade the right region, you have to do it with all the lines. Okay, that's why I drew 2 graphs and I showed you. Okay, and if you draw the right region, you will see that the 3 shading that you did converge at a certain point. I did that to show you. Okay, so as I said, if I'm doing some possible exam question the next set and I get some of these questions, I will do the graph work and come and show it to you, because I have to explain it to you. Okay, I can't just show you my notes and then stop. So I won't bring it in the starter because it takes a lot of time to explain, especially if whoever is watching, that is their first video on the platform. Okay, every video I approach it as somebody out there is watching it for the first time. Okay, that's why I start asking you to subscribe and all those stuff, because it might be somebody's first time. But if you've watched it over and over again, you can click that and off. It's just like 3-4 minutes or 3 minutes, and then go ahead and watch what I have for you today. Today our starter is circle theorem. It's not to scale. We've done videos on circle theorem. Okay, so the example, this is the diagram. That is 140. Okay, we don't know this angle and we are asked to find this angle. Okay, so now this is how the diagram is. Assuming I turn my script upside down, it will make more sense, because if this is 140, the angle at the center, then straight away that will be the angle at A will be 70. Okay, so if this angle is 70, this A B C D is a cyclic quadrilateral. So if this is 70 and you take 70 out of 180, then the angle at C, you take 70 out of 180, then the angle at C will be 110. Okay, so that is what I have explained here. Okay, so find the angle at A, this angle here. Okay, so if this is 140, 140 divided by 2 after is 70. Okay, so if that is 70 here, 70 at 110 will be 80. So this angle at C is 110. Okay, because of the cyclic quadrilateral. So that is the first one. Now, the second one is also circle theorem. BC is a chord. Okay, AB is a chord. If you've not been told, you should see it. AC goes through the center, so that will be the diameter. Okay, if I want to take the triangle ABC, this and this are chords and a diameter. So the whole angle, the two angles at B will be 90. Okay, I know this is 34. So 90 plus 34 will be 124. If I take it from 180, the angle at C will be 56. Okay, so that is my solution here. So angle at C here is 56. Now, the angle Y, this angle here, okay, this angle here, if I use this triangle here, okay, this is 56. I've been told this is 61. So when I add them together, I have 117. And if I take it from 180, then Y will be 63. So this Y here will be 63. There. Okay. So the circle theorem, the more you use it, the more it becomes easier for you to understand. Okay. Now today we are going to look at the introduction of surds. Okay. So now here today surds. Okay. Surds are numbers in square root form. Okay. So for example, square root of 2, root 3, root 5, root 7, root 11, root 13, 2 root 3, 4 root 5, 5 root 3, etc. All these are sets. Okay. Root 4 is a set, but you can simplify. The root of 4 is 2, so the answer is not a set. Okay. But I mean, if you have root 3, without the calculator, you can simplify. Okay. These sets are called irrational numbers. We have two types of numbers, rational and irrational. Okay, irrational, that is the spelling. Okay, these are states, they are rational. Irrational, okay, all other numbers are rational. Okay, because we said you can get them going forever, on and on and on. Okay, so if you find the square root of 5 on the calculator, okay, unlike 25, the square root of 25, that will give you 5, a whole number. You can get the square root of 5 and it will give you a number plus some decimals. You remember we did terminating and recurring decimals. Okay. Now, there are two main rules when you are dealing with sets. Okay, so I'm going to introduce the two main rules, and then tomorrow we'll take up from where we saw from. Okay, rule 1: if you have root A times root B, we've used this to solve some questions before I'm introducing it, and I said I'll come and introduce it. So if you have root A times root B, then your answer will be root AB. So if you have root 2 times root 3, your answer will be root 2 times 3, which will be root 6. The opposite will be true. Okay, two sets multiplied together to two numbers. Okay, so that is what I've just said. So two sets when you multiply it together, you multiply the two numbers. Okay, so for example, root 2 times root 3 will be 2 times 3, which is root 6. So for instance, if I have root of, follow me here, okay, root of 2 as my numerator and root of 6, okay, I can rewrite the denominator as root 2 over root 2 root 3. So this root 2 can cancel. Then my answer becomes 1 root of 3. Okay. Otherwise, it will be difficult to simplify. So that's why I said root 2 root 3 is root 6. But the reverse is also true. So like difference of two squares, your ability to look at a set problem and say that, okay, root 21, I'm going to break it down to root 3 times root 7, because those facts, I can see that in the numerator or the denominator and use it to cancel out. Then you'll be stuck. Root 5, root 2, root 5, or root 5 times root 2 will give you root 2 times 5, which is root 10. The reverse is also true. Root 3 times root 7, which will give you root 3 times 7, root 21. The reverse is also true. Okay, so if I say root 21 in an equation, and maybe I can cancel out with root 3 and root 4. In place of root 21, I can write root 3 times root 7. Okay, root 3 times root 5 will be equal to root 3 times 5, which is root 15. As I said, the reverse is also true. Root 3 times root 11 equals root 3 times 11, okay, which is root 33. So this is the first rule, okay. I think you've added to your flashcard. If it's not your flashcard, add it to it. Add this to your flashcard, okay. Now we are here. So root 5 times root 11 will give us 5 times 11 all square root, which will give us root 55. Root 7 times 5 will be equal to the square root of 7 times 5, which will give us root 35. Okay, so that is our first rule in sets that we'll be working mainly with. Okay, now the second one, let's look at it. So as I said, the reverse is also true. Okay, now the second one, the second rule, I've also used this before. Root A times root A equals A. Okay, so for instance, root 2 times root 2, using the first rule, will give me root 4 times root 2 times 2, which is 4. So root 4 is 2. So if I see root 2 times root 2, I can say the answer is 2. If I see root 8 times root 8, I can say the answer is 8. Okay, root 3 times root 3 will give me square root of 3 times 3, which is 9. The square root of 9 will be 3. Okay, so the reverse is also true. If I'm solving an equation says and the denominator is 3. Okay, and there's a square root on the numerator. In place of 3, I can write root 3 times root 3, and then the numerator and denominator will take care of itself, and I can simplify. Okay, root 4 times root 4 will be 4 times 4, 16, the square root of 16, which is 4. As I said, 4 can also be written as root of 16 or root 4 times root 4. Okay, if I'm trying to simplify, it says, okay, assuming I had guessed 4, I can break it down and write root 4 times root 4. Okay, now root 5 times root 5 will be equal to, if we apply the first rule, it will be root 5 times 5. It will be root 5 times 5, which is root 25, which will give us 5. The reverse is also true, okay? In maths, as you are getting the answer, remember the reverse is also true. So your way for you to be quick to answer these questions, so if there is a 6 and there is a root of 6 somewhere, I can write 6 as root 6 times root 6, because in the end I'll get root of 36, which will end up giving me 6. Root 7 times root 7 will give me root of 7 times 7, which is 49, which will give me 7. As I said, the reverse is also true. Root 8 times root 8 will give me root 64, which will give me 8. As I said, the reverse is also true. Root 9 times root 9 will give us root of 81. Okay, root of 81 is 9. So if I have 9 and I'm supposed to solve in sets, in place of 9, I can write root 9, root 9. Now root 9 can also be written as root 3, root 3, root 3, root 3. So if I'm solving it in root 3 and I have 9, I can write root 3 4 times, and I'll still get be able to simplify. Okay. In those cases, they bring it in the non-calculator paper. Okay. Now, root 10 times root 10 is 10, because 10 times 10 is 100. The square root of 100 will be 10. Okay, which will be plus or minus, but in sets we choose the positive. Okay, root 11 times root 11 will give us root 121. Okay, so 121 will give us 11. We still choose positive in sets. Okay, root 12 times root 12 will give us root of 144, okay, which is 12. Okay, so we can go on and on and on with these examples, but all I wanted to show you today is, as it goes forward, like root 4, 12 times root 12, you can also do it backwards. Okay, so like root 12, you can get 12, you can get 3 times 4, 3 times 4. So in sets, your knowledge about the times table is very, very important, because if you know your times table and you are to show that, in sets you get a lot of show that, prove that. Okay, so you may have to start from the answer and end, or from the left hand side and end on the right hand side, or start from the right hand side and finish at the left hand side. Okay, so some of these rules will help you a lot. Okay, so today I came to show you these two rules and introduce you to sets, which we'll do in the next few videos with other starter topics. Okay, I'm going to stop here. Go and think about what I've shown you today. Okay, if you've not seen sets and you are doing a higher paper, I did some possible exam questions. We applied it in some of the videos, but this is what said is. Okay, square root of numbers and stuff, irrational numbers. Okay, so just go and have a look. Okay, please subscribe, like, share. Okay, support the platform. Let's push the platform so that more people can see it. Okay, there is no point for somebody to go and rewrite a paper because of half a mark or 1 mark they didn't get. Okay, so who knows? Our platform can be the difference of somebody getting a C or a D. Okay, and help yourselves. Okay, thank you so much. Okay, for joining me in today's lesson. Please take care of yourself online. um Follow my notes slash script, especially today, is very important. Thank you for joining me today's lesson, and I'll see you in the next.